Hello viewers, welcome to the YouTube channel Roshni with Hina. Today I will discuss the topic Differential Calculus Basic Information. What is calculus? Calculus is a branch of mathematics that studies rates of change and how things change over time. Differential calculus is the study of the rates at which quantities change. Some important symbols in calculus includes the derivatives, integral and limit notation. What is differential calculus? Differential calculus deals with the study of rates of change and slope of curves. It involves finding derivatives of function. Derivative. The derivative of a function at a specific point is the slope of the tangent line to the curve at that point. It measures the instantaneous rate of change. The central concept in differential calculus is the derivative. The derivative of a function represents the rate at which the function's value changes as its input independent variable changes. It is denoted by f inverse x, dy by dx or df by dx, where y is the dependent variable and x is the independent variable. Rules of differentiations. The power rule. Differentiate each term by multiplying the exponent by the coefficient. The product rule. Differentiate each factor, then add them together. The chain rule differentiate the outer function, then the inner function multiplied by the derivative of the outer function. Common derivatives. The derivatives of a constant is 0. The derivative of x to the power of n is nx and bracket start n minus 1 bracket close. The derivative of sine of x is cos of x. Basic concepts and information related to differential calculus. The slope of a curve. The derivatives at a specific point on a curve represent the slope of the tangent line to the curve at the point. It provides information about the instantaneous rate of change of the function. Basic differential rules. There are several rules for finding derivatives, including the power rule, product rule, quotient rule, and chain rule. These rules are used to differentiate different types of functions. Application. Differential calculus has widespread application in various fields, including physics, engineering, economics, biology, and computer science. It is used to analyze and model real world phenomena involving change and rates of change. Limit concept. The concept of a limit is fundamental in differential calculus. The derivatives of a function at a specific point is defined as the limit of the average rate of change of the function as the interval around that point becomes infinitesimally small. Higher order derivatives. It is possible to take the derivative of a derivative, resulting in second, third, and higher order derivative. Higher order derivatives provide information about the curvature and concavity of a function. Optimization. Optimization calculus is used for solving optimization problems, such as finding the maximum or minimum values of function. This is valuable in various fields, including engineering, etc. Rate of change. Differential calculus is used to determine rates of change in various contexts. For example, it can be used to analyze the speed of a moving object, the growth of a population, or the change in a stock's value over time. Historical significance. The development of differential calculus is attributed to mathematicians like Isaac Newton and Gottfried William Leibniz, who independently laid the foundation for this branch of mathematics in the late 17th century. Applications of differential calculus. The derivatives of a function gives its instantaneously rate of change at any point. It can be used to find maxima and minima of function. Thank you for giving me the opportunity to share some basic information on differential calculus with you. Thank you for choosing Roshni with Hina channel. Kindly share, like, and subscribe.